We will continue working with exponential equations here, but they are slightly different. As you can see, the equation that I have chosen is an equation that has powers on both sides, but the basis of those powers are different. So what I need to do right here is basically I want to actually consider the base of the power with the complex exponent. So you are using the one that is the most complex one, the most complicated one. And definitely in this case is this one. The exponent here is x, the exponent here x plus 1. So I'm going to choose the number 4 as my a. So I'm going to choose the number 4 as my base for the logarithms. The next step is to take the logarithm with base 4 from both sides of the equation. So I have log of 5 with base 4 is equal to the log of 4 to the x plus 1 with base 4. Now, remember that you need to take logarithms with the same base. How you choose the base to be 4? You choose the exponent that is the most complicated one, and you use that base, the number 4 here. So at the next step, you are going to apply the power rule. In order to get the x and the x plus 1 out of the exponent. So you have here log of 5 with base 4 and is equal to, here you have two terms at the exponent. So remember, put it in parentheses and you have x plus 1 times log of 4 with base 4. Okay, now the beauty of that is that this is equal to 1 and you don't need to consider it anymore. So you go to the next step now, and the next step, let me clean my equation. I have x log with base 4 of 5 is equal to x plus 1, and that's it. Now, I haven't solved it yet. I haven't finished solving the equation yet because I need to have on the one side of the equation an x and on the other side of the equation no x at all. Unfortunately, as you can see right here, this is not the case. We can definitely see that I have a variable term right here, x times log with base 4 of 5 equals to x plus 1. So the constant, the only constant that I have is the number 1. This constant needs to stay here. And I pass all the variable terms on the other side. And I have x times log with base 4 of 5 minus x. Okay, good. So now I have two variable terms on the left side and the number 1 on the right side that stays alone, and it's fine. But this is not done yet, right? I need to combine those two terms. Can I combine them? Yes, I can. Why can I combine them? Because they are both variable terms. Okay, good. What's the coefficient of this term? It's log of 5. What's the coefficient of this term? 1. How can I combine them? I factor out the x. If I factor out the x inside the equation, inside the parentheses, what I have is log with base 4 of 5 minus 1 equals to 1. So now I can divide both sides by whatever is multiplied by x, my coefficient. So I divide both sides by log with base 4 of 5 minus 1 divided by log with base 4 of 5 minus 1. And the answer is x is equal to 1. X is equal to 1 over log with base 4 of 5 minus 1. Now, here I want to remind you that the only argument is 5. The 5 is the argument. The negative 1 that you have right here is a number that is subtracted from the logarithm. The log of 5 with base 4 is almost 1 something, 1.1 let's say. So you have 1.1 minus 1. And that's your final answer. Let's work on a similar problem as our second example right here. So the problem that we have right here again has two powers with different bases. The one is 2, the other is 3. So we cannot simplify them easily, we need to use logs. Again, what I do is I choose the log to be the log of the that has a base, the base of the power with the most complex exponent. So I'm going to use log of 2 and I will take the log of 2 from both sides of the equation. So let me do that. I have here log with base 2 of 2 to the 3x plus 1, and this is equal to log with base 2 of 3 to the x minus 2. Now, since on both sides I have exponents that they have two terms, I would prefer to put them in parentheses, only to avoid any problems, any mistakes, when I will apply the power rule. So I'm going to apply now the power rule of logarithms. I want to remind you that the power rule of logarithms tells me that if I have right here, let's say x to the k, then this is nothing else than the k times log with base a of x. So what I do is I bring the k down. Okay, so I bring down on the one side the 3x plus 1 in the parentheses times log with base 2 of 2, and on the other side I have x minus 2 again in parentheses log with base 2 of 3. Now this one is simply equal to the number 1. Why? Again, I remind you that the log of a with base a is 1. So this is the case right here. On the other side though, I cannot simplify anything because I have the log of 3 with base 2. So this should stay as is, and it's a number close to number 1.5. Actually, it's approximated to 1.58, this number right here. So you have here 3x plus 1 equals to x minus 2 times log with base 2 of 3. At the next step, what you want to do is to actually get rid of the parentheses, because you want to know which ones of those are your variable terms and which ones of those are your constant terms. So you have 3x plus 1 on the one side, and on the other side I'm going to distribute the log with base 2 of 3 to both terms of my parentheses. So I'm going to distribute that here, and I have x times log with base 2 of 3 minus 2 times log with base 2 of 3. Okay, excellent. Now I want to identify which ones of those are my variable terms. This one and this one. How do I recognize them? Well, they have an x. And which one of those are my constants? This one and this one. How do I recognize them? They don't have an x. Okay, and I continue. How? Like I do for a linear equation. I separate the variable terms from the constants. So the green terms will go on the left side, and the constant terms, the purple terms, will go at the right side. remember that the argument of the log is just 3. Now, am I done? No, I'm not done, because on the left side, as you can see, I have 2 variable terms, and what I need to do now is to factor out the variable. So I have x, and inside the parentheses I have 3 minus log with base 2 of 3 equals to negative 2 log with base 2 of 3 minus 1. And now I need to isolate my x, because that's my variable. How do I do that? By dividing both sides by the coefficient of x. And this is going to be nothing else than 3 minus log of 3 with base 2. That's it. Now, one thing that I want you to see right here is that you can simplify the coefficient of the x, and this gives you as an answer this fraction. Don't try to simplify this fraction, it's good as is.